lecture series on electronic devices and circuits. So in our previous sessions we have studied about the PN junction diode. In this session we are going to cover the numericals based on the PN junction diode. So here is our first example. The forward current through a silicon diode is 10 milliampere at room temperature 27 degree. The corresponding forward voltage is 0.75 volt. Calculate the reverse saturation current. Here eta is given as 2 for silicon diode. So first of all we'll write down the given values or given data. So first is ID, which is equal to 10 milliampere. VD, that is forward voltage across diode, is 0.75 volt. T 27 degree and eta is given as 2. So we can convert this temperature in degree to Kelvin, and for that what we have to do, we have to add 273 in this temperature. So when we add this 273 in this temperature, what will be the value of temperature T? So this temperature T will become 300 degree Kelvin. Okay, now what we have to do, we have to write down the formula for diode current. So Shockley's diode current equation. What is Shockley's diode current equation? We have studied in our previous session. So it is ID is equal to IS into e raised to VD divided by N eta into VT minus 1. Here this is the voltage, forward voltage, eta, VT, then forward current through diode and saturation current. So here we have to find out reverse saturation current. That means we have to find out the value of this IS. For this what we'll do, we'll put all the values, given values are there. ID is 10 milliampere, VD 0.75 volt, eta 2. Now this VT, we know what is the value of VT. VT is equal to K into Q upon T. Okay, this is the value of VT. So K value is given as 1.38 into 10 raised to minus 23 joules per Kelvin divided by into value of Q is 1.6 into 10 raised to minus 19 coulomb whole divided by temperature T. Okay, how much is temperature T given? It is 300. So when we do the calculation, this VT will be nearly equals to 26 millivolt. So by putting these values in this equation, we'll get ID is 10 milliampere, that is 10 into 10 raised to minus 3, which is equal to IS into e raised to VD is 0.75 divided by eta is 2 into VT is 26 millivolt, that means minus 3 minus 1. Okay, so we can solve this and we can find out the value of IS here. So 10 into 10 raised to minus 3 is equal to IS into, now this will solve on calculator and we'll get the answer 0.75 divided by 2 into 26 millivolt is equal to 14.423. So e raised to 14.423 minus 1. After that we can calculate the value of e raised to 14.4. So it is, we can find out e raised to 14.423 is equal to this much. Okay, and minus 1. So from this we'll subtract, minus 1. So our answer will become, so here our answer is 1835815.684. So I will write down 10 into 10 raised to minus 3 is equal to is into 1835815.68. Now we'll take this term to this side to calculate the value of is. So is will become 10 into 10 raised to minus 3 divided by 1835815.68. We can do that on calculator. So it is equal to 10 into 10 raised to minus 3 divided by 1835815.68, which is equal to 5.44 into 10 raised to minus 9. So is is equal to 5.44 into 10 raised to minus 9. That is nothing but 5.44 nano ampere. So the reverse current is 5.44 nano ampere. Now you can compare. The forward current is 10 milliampere and reverse current is 5.44 nano ampere, which is very less compared to the forward current, because this reverse current, this flows due to the minority carriers. Now we'll see the next example. So next our example, a diode operating at 300 degree has forward voltage of 0.4 volt across it when the current through it is 10 milliampere, and 0.42 volt when the current is twice as large. What values of I0 and eta allow the diode to be modeled by the diode equation? So here temperature is given 300 degree Kelvin, V1 is given as 0.4 volt, and at that time our current is 10 milliampere. You can call it as I1 or you can call it as a ID1. So we'll call it as a ID1. V2 is given as 0.42. At that time our I2 is equal to I2, or you can call it as ID2. It is equal to 20 milliampere. What we have to calculate here? We have to calculate eta and is. I0 is nothing but the reverse saturation current, or you can call it as a is, which is equal to I0. I will write down here. So at temperature T equals to 300 degree Kelvin, our VT voltage is given as 26 millivolt. The calculations I have shown you in previous example. So I will write down directly here as a 26 millivolt. Okay. So what we have to do now? For the given data, we can write down the two equations. Since there are two currents given, so we will write down two equations. Let's consider ID1 is equal to is into e raised to VD1 or V1 divided by eta into Vt minus 1, and ID2 is given as is into e raised to V2 divided by eta Vt minus 1. So these are the two equations. Now we'll put the values of ID1 and ID2, similarly V1, Vt in both the equations, and we'll write down. So it will become ID1 is 10 milliampere is equal to is into e raised to V1 is 0.4 volt divided by eta we have to calculate. Okay, so we'll write down eta as it is, and Vt is given as 26 millivolt, means 26 into 10 raised to minus 3 minus 1. Similarly, for this ID2, it is 20 milliampere, which is equal to Is into e raised to 0.42 divided by eta into 26 into 10 raised to minus 3 minus 1. Okay, but here if we see eta and Is both are unknown to us, we have to find out, and in both the equations we are having eta and Is unknown. So what we'll do, we'll take the ratio of this equation and this equation. So we'll call this as equation number 1, this as equation number 2, and we'll take the ratio of equation 1 with equation 2. Okay, and by taking that ratio, all what we'll do, dividing equation 2 by equation 1, we'll have 20 milliampere divided by 10 milliampere is equal to Is into e raised to 0.42 divided by eta into 26 into 10 raised to minus 3 minus 1 divided by Is into e raised to 0.4 divided by eta into 26 into 10 raised to minus 3 minus 1. So what will happen here, this Is and this Is will get cancelled. Similarly, 20 divided by 10, it will become 2. Okay, so this equation will become 2 is equal to e raised to 0.42 divided by eta into 26 into 10 raised to minus 3 minus 1 whole divided by e raised to 0.4 divided by eta into 26 into 10 raised to minus 3 minus 1. Now we have to solve to find out the value of eta. So what we'll do, we'll take the log of this equation. We'll take log to this side and log to this side. So when we take log in our calculator, we have to use this button. Okay, so log of 2 is equal to how much? It is 0.693. So log of 2 will become 0.693, which is equal to 0.42 divided by 26 into 10 raised to minus 3 is 16.15. So it is 16.15 divided by eta minus this 0.4 divided by 26 millivolt is 15.38 divided by eta. Now this eta will take to this side. This equation will become 0.693 eta, which is equal to, now 16.15 minus 15.38, it is equal to 0.77, and taking the eta, to find out the eta, this we have to take to this side. Therefore the value of eta will get 1.11. Okay, so by this way we have calculated the value of eta. Now to find out the value, one more value we have to find out, Is. To find out the value of Is, we can put eta value in equation 1 or in equation 2. So here we'll put value of eta, putting eta is equal to 1.11 in equation number 2, will have 20 milliampere is equal to Is into e raised to 0.42 divided by 1.11 into 26 millivolt minus 1, and we have to solve this further. So this term we have to take to this side to get the value of Is, and solving this further will get Is is equal to 9.69 nanoampere. So by this way we have calculated the value of eta and reverse saturation current Is for this numerical. So hope you have understood both the numericals. Now we'll solve one more numerical on this. So what is that numerical? a diode with a reverse saturation current of 10 raised to minus 12 ampere and another with 10 raised to minus 10 ampere are connected in parallel. If the total current of the circuit is 2 milliampere, calculate the voltage across the diodes. Assume eta is equal to 1. So what happens here? Two diodes are given. That two diodes are connected in parallel. Through one diode the current is, reverse saturation current is 10 raised to minus 12 ampere, and from another diode the reverse saturation current is 10 raised to minus 10 ampere. Okay, so we have to find out what? Calculate the voltage across the diodes. This voltage we have to find out. Since both the diodes are connected in parallel, the voltage across this diode, both the diodes will be same. Across this diode we have V volt. Similarly across this diode we have V volt. Okay, so we will solve this. So current through diode D1, first of all we'll find out that how much is that. It is given as current through diode D1. It is ID1 is equal to IS, we'll call it as a IS1 into e raised to Vd minus eta into Vt minus 1. So instead of Vd we'll also write down V. Similarly current through diode D2 is given as ID2 is equal to IS2 into e raised to V divided by eta Vt minus 1. After doing that, what we have to do? In the given equation, what is given? If the total current of the circuit is 2 milliampere, means the total current of the circuit I is given as 2 milliampere, and through diode D1 the current is 10 raised to minus 12 ampere, and through diode D2 current is 10 raised to minus 10 ampere. That means this current I, it gets divided at this point as a ID1 and ID2. So we'll write down here total current of the circuit I is equal to ID1 plus ID2. So what we'll do? We'll call this as equation 1, this equation 2. So we'll add equation 1 and equation 2 to get the total current of the circuit. So total current of the circuit I is equal to IS1 into e raised to V upon n Vt minus 1 plus IS2 into e raised to V upon n Vt minus 1. So here in this equation we'll neglect minus 1 term. Okay, by neglecting that minus 1 term, our I will become IS1 into e raised to V upon n Vt plus IS2 into e raised to V upon n Vt. Okay, now we'll put the values of this current I, the value of eta and Vt. So I is given as 2 milliampere, it is equal to IS1. IS1 is given? Yes. IS1 is given as 10 raised to minus 12 ampere. So it is 10 raised to minus 12 into e raised to V upon eta is 1 into 26 millivolt plus IS2 is given as 10 raised to minus 10 into e raised to V upon 1 into 26 millivolt. So the E term that we can take common from these two terms will get 2 milliampere is equal to e raised to V upon 26 millivolt into 10 raised to minus 12 ampere plus 10 raised to minus 10 ampere. And further we'll solve this. This term will take to this term will take to this side to find out e raised to v term. So e raised to v upon 26 millivolt will become 2 milliampere divided by this 10 raised to minus 12 plus 10 raised to minus 10. So that is nearly equal to 1.01 into 10 raised to minus 10. By dividing this 2 milliampere divided by this term, will get the answer 19.8 into 10 raised to 6. After this, we'll take the log for both the sides. Taking the log for both the sides, we'll get this e will get cancelled when we'll take log. So it will become v divided by 26 millivolt is equal to log of this term will become 16.80. Now dividing the 16.8 by 26 millivolt will get the value v. So by doing that we'll get the value v. So therefore v will be equals to 0.43 volts. So here we have obtained the voltage v across diode D1 and D2. So hope all of you understood how to solve the numericals based on PN junction diode. Thank you for watching the video.